Hey math enthusiast, I'm here to go over the notes from section 1.2, which deals with segments and congruence. Now the notes start off with the ruler postulate. Now just to clarify, a postulate is a rule that we accept in geometry without proof. So there's no way to actually prove a postulate because it's essentially a beginning rule. All right, something you start with and that you can use later to prove theorems. So a theorem is a rule that you can prove. So as far as the ruler postulate is concerned, first thing I need to know is a little bit about my number line. So we have line AB, where obviously A and B are the names of specific points. Now below that, I'm going to add in the coordinates. So x1 and x2 represent coordinates. All right, they're essentially just values on the number line. Maybe A is at 2 and B is at 6. Next thing is locating the distance between those 2 points on my number line. So once again, we still have points A and B, and if I want the distance from A to B, or the length of segment AB, I'm going to do x2 minus x1, and then I'm going to take the absolute value of that. All right, the reason I'm using absolute value here is because distance anywhere is always positive. So for these examples down below, and now we're using this number line that they give us. First one I want is A to D. So A is here, and D is here. So we'll call this our x1 and this our x2. So if you remember my formula from up above, what I'm going to do is x2, which is 0, minus x1, which is 9, and I'm going to take the absolute value of that. Well, you're subtracting a negative, so I know that's going to become positive. So it's the absolute value of 9, which just gives me 9. Next one I'm worried about is BC. So BC, once again, we'll say this is our x1, this is our x2. So I'm going to have absolute value of -4 minus -6. Subtracting a negative, so I know that's going to turn into positive. -4 plus 6 gives me positive 2, which is just 2. Take a minute and try that last one on your own for BE. Looks like BE is going to be 8 units long. Next, we come across the segment addition postulate. So in this case, we have our 3 collinear points, A, B, and C. They all lie on the same line or segment. And what this postulate tells me is that if I add up this piece on the left, AB, plus the piece on the right, BC, together, those two pieces are going to make up the larger or longer segment, AC. That's all this theorem's saying, is that if you add up 2 smaller pieces, together they're going to equal the whole, or the longer segment. So for this first example, I just want to start off with the letters. So in this case, we have G, H, and J, which are all collinear. And according to the segment addition postulate, GH plus HJ is going to equal GJ. So now let's just replace what we have. So GH is actually 6.7. HJ is actually 8.6. And then obviously what I'm trying to solve for is GJ. So when I add those two up, I end up with 15.3, which is the length of segment GJ. For the next one, start off the same way with the letters only. This one should look familiar. It's the same setup we have up above from the notes. So AB plus BC equals AC. First thing they give me is AB, which I know is 25. But then the next piece they give me is this 54, which represents the whole thing. So I know AC is 54. So obviously in this case, I'm looking to solve for BC. So now we just have some simple algebra. I'm just going to move that 25 over to the other side. So in this case, it looks like BC equals 29. So for this next example, let's start off the same way with just a sketch. So we have 3 points, G, F, and H. And the specifics tell me that G is between F and H. So it doesn't really matter where you put F and H as long as G is in between those two. Then they give me some lengths. So FH, which represents the whole entire thing, is 4x minus 1. They also give me FG, this piece on the left, which is x plus 6. And they give me GH, which is 8. So remember, start off with the segment addition postulate with the letters only for the segments. So I have FG plus GH, segment on the right, equals the whole entire thing, FH. Now let's replace one at a time. FG is x plus 6. GH is 8. And FH at the end is 4x minus 1. Combine some like terms real quick. X plus 14 equals 4x minus 1. Balance our equation. It looks like I end up with 15 on the left, 3x on the right. So it looks like x equals 5. All right, you can always check your work as well. If x is 5, then I'm saying that this segment on the left is 11, segment on the right is 18, and then the whole thing, when I plug 5 in here, should be 19. And it looks like it works out. For the next scenario, start off the same way. You have 3 collinear points, S, R, and T. R and T are on either end. S is somewhere in the middle. And then they give me some lengths. So RS is x plus 1. ST, this segment on the right, is x squared. And then RT, which is the whole thing, is 21. So start off with the letters only. According to the segment addition postulate, RS plus ST is going to equal RT. Replace what you have. RS is x plus 1. ST is x squared, and then RT is 21. First, I would rearrange your equation so it's in standard form. So x squared plus x plus 1 equals 21. Next, I would set it equal to 0. Since we have an x squared term and an x to the first and a constant, then it looks like I'm going to have to factor. So now when I break it down to my two binomials, I know it's going to be x and x. Factors the negative 20, they're going to add to positive 1, which is going to give me 5 and 4, and then add in your signs. So it looks like in this case x could equal negative 5 or positive 4. Well, it looks like if I were to plug in negative 5 right here for RS, I'm automatically going to end up with a negative length. So that negative 5 is out. So it looks like my solution should be positive 4. So if I plug that in, RS is going to be 5, ST is going to be 16, and if I add those two up, I do get 21. Take a minute, try this next one out on your own, and I'll reveal the answer in a couple seconds. So after we set up our equation and solve, it looks like we end up with x equals 7.5. And after I go back and plug it in, it looks like AB is going to be 79, BC is going to be 27, and then the whole thing, AC, is going to be 106. Which checks out. For For the next example, I'm given several different points, E, F, G, and H. And I'm just trying to determine whether or not they are congruent. So that's my first introduction of this symbol. All right. What that essentially means, as I said, is it means congruent. And in that case, what I'm saying is that the two segments that I'm going to sketch out are the same. So I've sketched out my two segments, EF and GH. And as I said, I'm trying to determine, are they actually the same? Are they congruent? So the physical segments themselves, so EF compared to HG, are they the same? One way to determine if they are congruent is, do they have the same length? Well, the length of EF is 4 units, and the length of GH is also 4 units. So in this case, if they have the same length, then they are going to be congruent. Now, the big difference is between congruence and equality is when it comes to equality, I'm talking about the length. All right, the length of my segments. So 4 units is obviously going to be equal to 4 units. When I'm talking about congruence, I'm talking about the physical segments. So I'm referring to segment EF and segment GH. So like the segments I drew in my picture over here on the right. So when you're using equality, I'm talking about values, numbers. When I'm using congruence, I'm talking about the pieces, the segments, or maybe the shapes, which we'll eventually get to. So for this next example, let's sketch out a picture of what they're describing. So we have point G between F and H. So G here, somewhere in the middle, and F and H. Now, the next thing they mention is that FG is congruent to GH. Now, remember, this essentially means that they are the same. So in other words, their lengths are going to be equal. So whatever FG is, it's going to be equal to GH. Now, to show that in my picture, what you can add is a little tick mark. So I'll put a little tick mark on FG and a little tick mark on GH. Automatically, that tells me that the two are equal in length. Next, let's add what they give us. FG is 5x minus 7. Next thing, GH is 11 plus 2x. Now I want to find the length of each segment. So let's use what I stated before. I said that, you know what, FG is supposed to be equal to GH if they're congruent. Now let's fill in what I do have. Well, FG is 5x minus 7. And GH is 11 plus 2x. So I'm going to end up with 3x equals 18. And it looks like x equals 6. So when I plug this back in, it looks like my lengths are going to be 33 and 33.